to start our next presentation with Fawzi Mohamed from CSCS. We're going to talk a little bit about machine language research.
Yeah, thank you for having me here. I want to talk on the Alps research infrastructure at CSCS and how we try to enable world-class machine learning research in Switzerland. So this has been already said a bit that machine learning started quite some time ago, but recently there has been a change, also as Immanuel pointed out, that ML has improved to the point that many new applications are possible and there is economic and social impact. And depends on increasing amount of data, transforming models, scaling laws, and with that comes the need for storage and processing power. And there are questions about if we are reaching the limit of scaling, but more and more there are optimization also on smaller models or thinking about a specific problem, but no matter exactly what happens, computational effort is still required. Might shift a bit from training to post-training and inference. And inference is a bit different because it's more parallelizable, but it's still an important and a needed thing. Infrastructure is key for modern AI development. If you don't have infrastructure, you cannot have modern AI. And accuracy and computational power are directly related. And you can see a bit the rate of increase of flops that is really extreme. So I'm from CSCS, the Swiss National Supercomputing Center, that I guess most of you know, but I will quickly say that we are a unit of the Swiss Federal Institute of Technology of Zurich, ETH Zurich, 91 in Manno, and we are now here in Lugano, very close by. The mission is to develop, promote, and provide services for the Swiss research community in high-performance computing and data management, support and foster Swiss innovation and competitiveness, and enable world-class scientific research by pioneering and supporting leading-edge supercomputing and data technologies. So we are 127, I guess, or we were, staff member, 25 nationalities, and 30 million yearly budget. We are using today 11 megawatt of power. And our users are researchers from user lab, can submit task where you can, we optimize scientific applications, and also to Meteo Swiss, SKA, and SwissAI Initiative. SwissAI Initiative was presented before by Immanuel, and I will talk a bit more. So ALPS is a research infrastructure connected to experiment, computational science, and the world. And CSCS has long history of accelerated computing and cloud computing in HPC. And ALPS is 2,688 nodes. These are for the AI part are Grasshopper. And this is how it looks. It allows to create dynamic clusters, as Ben also specified, and what we have is several versatile clusters, we call them, and Clariden is the one for AI. We have geo-distributed hardware and is funded by the federal government. This is grasshopper, 2 blades. If we look, this is what it looks like. One node is 4 grasshopper super chips with a fast interconnect connection all-to-all within all 4, and then the slingshot network card that go to all the other nodes. And okay, this is where we are. The supercomputer has a place to be, and there is free cooling from the Lugano Lake. Now, Alps is now the number 7 of the top 500. But if you look, the grasshopper have a lot of spots, top spots in the green top 10. But Alps is the only one in the top 10 overall. And the reason for that is that bringing up new infrastructure is always challenging. And the hardware is a good choice. It's very suited for machine learning, but we had to collaborate quite a bit with HP and NVIDIA to actually be able to deliver on the performance and really make it that it works as a whole system. Obviously, there are delays. Grasshopper is ARM, and this actually has not been very painful. ARM is quite well supported because of also all phones and so on. We hadn't a lot of issues there. But unified memory created a lot more of issues. Slingshot is nice, but when it fails, it affects everything, and initially it happened. Network isolation is possible. Cooling and power, we have a very good team to be careful when both systems were working, and storage is Lustre-based and now also VAST. It's not just the hardware, we also have software part is quite important. We have what we call vServices, which is infrastructure as code. This is quite important for us to be able to iterate quickly and fix the things and get new versions, test them in a different place, and then see that they work and deploy on all the machine. We still are mostly Slurm-based because it's locality and topology aware. The first scheduler works well when it's overbooked, and we have a lot of experience in-house. This doesn't mean that we aren't looking at other things. In fact, we are looking and we are using also Kubernetes for the supporting services for machine learning, both for supporting service like Slurm controller, but also for other things. Kubernetes can be tricky for multi-tenancy, but it's quite good for services, as said, 1DB inference service. And we are starting to use actually, looking at the first application really on GPU based, mostly towards inference. Pre-training and so on, there isn't a lot of need. Slurm works very well, but for inference it looks more interesting. Sorry. User environment, we use a container-first approach to leverage the container developed by vendors, in particular by NVIDIA and users. We define hooks to take advantage of hardware. We need to help a bit to navigate multi-architecture container, because we have both x86 and ARM nodes, and some users think it's a container, it works everywhere, but it's architecture dependent, obviously, and you have to then build for multiple architecture. We use a TOML file to define all parameters, so that there is a declarative interface to construct and persist and share a containerized environment. It's integrated with Slurm, and we are migrating towards Podman. UENV has been presented before by Ben. Stackinator, stack-based method to build optimized software stacks, because we don't want to necessarily have to rely only on vendor-based. Being able to be independent on that is very important, and there UENV plays an important role. GPU usage monitoring tools, there will be also a presentation on that, is an important place where we invested some effort to make user aware of how they use our infrastructure, if there is need to improve their program or things like that. Other pieces that are important to complete machine learning infrastructure is Firecrest. That's an interface to access basically all the HPC infrastructure in a modern RESTful API, for example, to do workflow. We are developing also an UI based on that. And Jupyter notebooks are available. So SSH is still the main way to access our cluster, but these alternative approaches are getting more and more important, and we think in the future will be even more so. So we are looking at having an interactive queue with node sharing, especially for things like Jupyter Notebook. It's not there yet, but it's in development. And we switch to Valdur. It's a user portal, and to manage the user and the community. It has a marketplace and allows self-serving. At the moment, we are in the initial phase, in the sense we are using Valdur. It's working, but we are still mostly providing the allocations or the resources ourselves. It's not the user that comes and buys them from us. It's not completely yet to self-serving, but this is supported by Valdur, and it integrates well also with external other provider like Lumi, or for example, a cloud provider could be integrated. And this is an important point in being able to bridge the things from HPC to more to cloud or other approaches. Security, clearly without security our service will quickly become unusable, and security has always been important for HPC, but with ML we had to be more careful about some things. ML has high stakes. There is a lot more of interest in it. And also it's an attractive target because ML hardware is typically powerful and well connected. And also the development speed of code base is quite fast. This means that there are more options to sneak in malicious software. And for example, through model poisoning, when you convince someone to load a model and you think loading a model, it's just data, it's just the weights, but internally it uses the Python pickle, and you can embed arbitrary Python that executes whatever, and then there have been issues related to that, or dependency confusion. Again, these are not things that are specific only for ML, but we got more exposed to those things via ML. Also there, for example, PyTorch dependencies, poisoning also in that case. Another point is data gathering. Collects large data set that are often from public internet data. And this is something that was somehow a bit discussed already before, but AI crawlers have increased the cost of hosting, for example, of Wikipedia. So they are not so well seen as good citizens. Also, they are seen as profiting or stealing and giving little back. And this led, for example, to development of so-called tar pits that are things like Nepenthes or Iocaine that try to slow down or poison the collection of data, of downloading data. And we, as center, normally we try to be neutral and leave the decision to others, or more the ethical parts, and so discussion is taken place on place. But when it actually goes to the infrastructure, you have to take care and you have some time to decide things. For example, we don't allow crawling from Alps infrastructure. This, as policy, it's not allowed to do just web crawling. You can download. We have internet. We don't want to remove internet connection from our infrastructure, but we cannot support things that might affect also all the user of our infrastructure. Because if you get blacklisted from DNS or from Cloudflare or the big provider, then you have an issue. And this is not something that you can just delegate. We have places where this is more allowed, but it's a discussion that has to be done. For example, there is the Koyo data set, which is an image text data set, quite widely known. It comes from the common crawl. Common crawl is the text part, and the images are not part of the common crawl. And many images are now missing, and if you try to download them, many of them are now, could get you malware or these kind of things. So clearly you need the data for AI, but getting it is not always so easy, and it has challenges. It's also not just the software, it's clearly also the people. We have an internal team, more focused, but everybody at the center supported and made it possible to have Alps and Clariden and the ML infrastructure work. We are looking at other things like inference service, Sailor, or CodePort AI, and we collaborate with the SwissAI Initiative, which is the major user of our infrastructure for the machine learning platform. As said before by Imanol, the goal is to develop know-how and talent and build trustworthy generative AI aligned with Swiss values and make the resources available for the benefit of Swiss and the whole world. This I can skip the presentation this morning of Imanol. So we begin to have some initial things, some usage of our infrastructure. For example, from the sustainability vertical, streaming large volume of data, doing the downsampling, pre-training of climate models. These are all things that are currently in progress on Clariden. And the health vertical also handling sensitive data, personal identifiable information. This is somewhat new for us because as a supercomputing center, we were more used to scientific data, open data that had no big restriction. Now we are beginning to handle also sensitive data, and this brings in new challenges. We are trying to make it so that we are as oblivious of the data as possible, but this is something still in active development, and we have to see. SwissAI is also looking for public-private partnership. If you are interested, you can contact them. Our infrastructure is not just usable by academia, but also from through the user lab is if you have your project accepted, then you can use our infrastructure. You can also simply use it if you pay for it. This is more pay as you go. It's a standardized offering that gives access to our service catalog with low barrier of entry, and there are tariffs for different one for academia and private usage. And industry also can use it, but has different pricing. So to conclude, building a good infrastructure for machine learning is challenging and an ongoing process. We have hardware that is well suited for machine learning, and software platform has many pieces. We try to balance flexibility with user friendliness. We try to focus on it's missing on what to provide and not duplicate work that is already being done in the open by others, and leverage all the good open source work that is being done. The first results are showing, and we manage this thanks to the good collaboration with our partner, HPE, NVIDIA, and the SwissAI Initiative. Thank you.
Thank you, Fawzi. Any questions?